Hello everyone. Today we'll learn about the principle of inclusion-exclusion, also known as PIE, a powerful tool in counting and probability. Let's start with an example to demonstrate where it's used. Imagine that some of the students in your class play soccer, some play basketball, and some play both. You want to find the number of students that play either sport. There are a few ways to solve this problem. We could use a Venn diagram like the one on the left. Looking at the diagram, all we have to do is count the number of people that are in either circle, for a total of 9 students who play either soccer or basketball. But let's see if we can solve the problem without a diagram. There are 5 soccer players and 6 basketball players, so we can just add 5 plus 6 to get our answer. But wait, 5 plus 6 is 11, which is more than our previous answer of 9. What happened? We have 2 students who play both sports, and we counted them twice, as part of the 5 soccer players and as part of the 6 basketball players. This is called overcounting, and we have to fix this by subtracting 2 from our initial count of 11 to get 11 minus 2, which is 9, our answer from before. The principle of inclusion-exclusion tells us exactly how much overcounting we will need to fix when we count items with many different labels. In our example, the items were students, and the labels were which sports the students played. When we have 2 possible labels, PIE states that the number of items with either label equals the number of items with the first label plus the number of items with the second label minus the number of items with both labels. In terms of our Venn diagram, that would be the number of items in the first circle plus the number of items in the second circle minus the number of items in both circles. Again, 5 plus 6 minus 2 equals 9. With that in mind, let's solve a problem from the AMC8. In a town of 351 adults, every adult owns a car, motorcycle, or both. If 331 adults own cars and 45 adults own motorcycles, how many of the car owners do not own a motorcycle? If we take the number of car owners and subtract the number of adults who own both a car and a motorcycle, we will have the answer we want. Let's use what we know in the formula for PIE. The number of adults who own either a car or a motorcycle is 351. The number of car owners is 331. And the number of motorcycle owners is 45. And we'll let x be the number of adults who own both. Rearranging this equation gives x equals 331 plus 45 minus 351, which comes out to 25. So the number of car owners minus the number of adults who own both is 331 minus 25, which is our final answer of 306 car owners who do not own a motorcycle. That's it for this video, and we hope to see you again soon.